Hey guys, it's Mr. Ray here with our next lesson in quadratic equations. Today we're going to learn about a third form of a quadratic equation. We've already learned about standard form and we've spent a lot of time on vertex form. So we're going to add our third and final way of writing a quadratic equation. So we've got our standard form and our vertex form. We've learned those. Today we're going to do the factored form. So the factored form, it's written in factors, and that's why it's called factored form. It starts off the same as all the others, y equals a, and the a value is the same as the other two forms. But then to the right of the a, we've got two factors, x minus r. R is just a placeholder for a number, and x minus s. So you can see why it's called factored form, because it's factored. Everything, we've got three things here multiplying that actually create the y coordinate given the x coordinate that you plug in. Now the cool thing about the factored form, if you remember, the vertex form gives you the vertex, and the standard form actually gives you the y-intercept, which we'll learn a bit more about that. The y-intercept is c. So there's the y-intercept, and we already know that in vertex form, h comma k is the vertex. So we've got the y-intercept from that form, the vertex from vertex form. Now the other points that we talked about at the very beginning of this unit, key points on a parabola, the graph of a quadratic function. The only thing we're missing are the x-intercepts, and that's exactly what the factored form can give us. So that's where the value of having an equation written like this. And in fact, if you see an equation, you can pretty much pull out the x-intercepts just by looking at, in this case, what r is and what s is. And both of these are the x-intercepts. Okay, and just a reminder, the x-intercepts are the values along the x-axis. If I quickly refer to a graph here, so they're going to be the points that the parabola touches along the x-axis. Okay, and just a reminder, it is possible. Most of the time, it will have two x-intercepts. Sometimes it'll just have one, and sometimes it won't have any. So this form may or may not happen sometimes. Okay. If it does have x-intercepts, most of the time you can write it in factored form. We'll talk more about the other situations later in the unit, but for now we're just going to look at examples where we can see the equation in factored form and get the x-intercepts directly from that equation. Okay, now let's start off with an example. So we've got, here's our equation here of a quadratic relation. We've got y equals 2 bracket x plus 1 bracket x minus 7. And remember, we're trying to make it look like this. So if I just wrote the template above here, it's y equals a bracket x minus r bracket x minus s. So if we can figure out what r and s would have to be for it to become this equation, then we've got ourselves our x-intercepts. So the a value is very straightforward. The a value would be 2. And let's go down here just to show. So since the equation is written this way, you might think that, well, maybe r is 1, but that would be wrong, because if you plug in r equals 1, then this is x minus 1. It's not x plus 1, which it needs to be. So it's kind of like the vertex form. When you're looking for your h value, you just take the opposite sign of that number. So in this case, r would be -1, and s would be, in this case, it's not -7, it's +7. +7. So remember that those values are the x-intercepts. So I'll write them right here, x-intercepts equals, and I could write them as points, or I could just say the values. because we know the y-coordinates of the x-intercepts will always be 0, because y equals 0 along the x-axis. So I'll just put -1, 7. Those are the 2 points. So you can see how quickly it is, if you have an equation in factored form, to figure out what the x-intercepts are. Okay, so we can go ahead. It says sketch the graph, and it also says label the x-intercepts, the vertex, and the axis of symmetry. Okay, so we didn't talk about the vertex. Let's label our x-intercepts. So we got -1, and we have 7. Okay, well, what do we do about the vertex? Well, let's kind of go back and learn a bit more about how to do this. So, okay, so the axis of symmetry, since these two x-intercepts are along the same y value, basically they're kind of parallel on a horizontal line, one thing we know is the axis of symmetry is going to be halfway between these 2 points. Okay, so I'm going to say axis of symmetry, and it's always the equation is always x equals a number, and that number will be, you know, halfway between these two. So I'm going to start off x equals. Now, how do I get the point that's halfway between? Well, that's kind of like taking the average of these two values. So it's like the average of -1 and 7. And the way we do that is we add them together and then divide by 2, just like you would with, say, a quiz mark. Add the 2 marks together and divide it by 2. So it's the same thing with the x-intercepts. So I'm going to say -1, which is that x-intercept, plus 7, and then we divide it by 2. And quickly see that's 6/2, which is 3. So the x-axis of symmetry is x equals 3. Okay, so that saves you some time from just kind of eyeballing it to see what you think it is, and then you might be a little bit off and have to redraw it. So this is exact. This is the best way to do it. So I drew the axis of symmetry a little bit to the right just so you can see the dashed lines, but we know it goes through x equals 3. Now, so it's asked us to label axis of symmetry, so let's do that. Axis of symmetry, x equals 3, and I've got my, I don't think I have to label, well, maybe I will. We'll call that x-intercept, and there's another one there, just to be totally clear. Okay, now how do we get the vertex? Okay, well, the vertex, if you remember when we drew our picture, the vertex is on the axis of symmetry. Okay, so it's somewhere along that line. Right now we don't know where, but if it's along that line, that tells us that the x-coordinate of the vertex is 3. So down here I'm going to write vertex, and I already know the x coordinate is the same as the axis of symmetry equation, x equals 3. Okay, so how do we figure out where that point is? Is it up here? Is it down here? Well, we've got the equation that's going to tell us that. So I'm going to write out, let's do it right here, y equals 2x, sorry, 2 bracket, x plus 1. Okay, so the x is 3. We know the x coordinate that we're going to use is 3 because that's the vertex's x coordinate. So that's 3 plus 1, and it's 3 minus 7. Okay, now let's simplify this. So we got 2, and then a 4, and then a -4. And the interesting thing about this, every time you do this little exercise to find the vertex, if you're given the x-intercepts, these two numbers will always be the same but opposite sign. Okay, because it just has to do with how far apart, how far the x-intercept is from the axis of symmetry. So this one's 4 higher, this one's 4 lower. That's where those numbers actually come from. So when we multiply this out, we get fairly big number. That's -16 times 2, so -32. So unfortunately, since the scale was already written here, I'm not going to be able to put that on, but you know, let's just kind of pretend it's down here. Now, actually, no, that's not it. It's along here. So let's just say we had a negative 32 here. So it's right around there. Okay, so probably should have thought ahead when I did this equation, try to get something a little closer, but it is what it is. Let's just go with what we've got. So that is the vertex. Let's label it. And now you can see I've got I got two x-intercepts. I've got the vertex, and that's enough to do a more than adequate sketch. That gives us the three most important points. So remember, when we're sketching or graphing, do a little cup where the vertex is, have them kind of point towards where the x-intercepts are in this case. And there we go. So that's pretty powerful. We're able to, given the vertex, sorry, the factored form of a quadratic equation, we can get the x-intercepts very quickly. And then from the x-intercepts, we can get the vertex with a little bit of work. We got those 3 points, and we can do a pretty good sketch. Those are by far the most important points. Okay, so that's your first experience with factored form. You can see we're going to use factored form if we want to find the x-intercepts. Okay, let's try the same activity, brand new equation here. We've got, so again, find the vertex and x-intercepts of this quadratic relation, sketch the graph. Okay, so pretty much the same as before. So first thing we do is the x-intercepts. Okay, and again, if you need to do this at the beginning, you can put your x minus r, x minus s above, and then say, okay, what would r have to be? R would have to be negative 3. So I'm going to skip putting r equals here, just go right to the x-intercepts. And in this case, x minus s, same as x minus 5, so that means s would be positive 5. So there's my two x-intercepts very fast. Go plot them here. There's my first one, there's my second one. Okay, then we're going to do the axis of symmetry, which will help us find the vertex as well. And that has the equation x equals, and then we basically add these two together, the x-intercepts, divide by 2. So negative 3 plus 5 is 2 over 2. So axis of symmetry is x equals 1. So it's right along here. Okay, and so let's label these things like we did before. Axis symmetry, and that's x equals 1 this time. Here's an x-intercept. Here's another one. And the last thing to find is the vertex. So remember, once we've got the axis of symmetry, that's given us the x-coordinate. So we know the x-coordinate is the same basically as the axis of symmetry. Since it's on that line, it has to be x equals 1. And then in order to get the y, we're going to actually substitute x equals 1 back into the original equation. Okay, so that's y equals 4. And then we have bracket x plus 3, so that's going to be 1 plus 3. And then it's going to be 1 minus 5. So that's equal to 4, bracket 4, and then that's negative 4. So remember I said these will always be the same number but opposite sign. It's just a coincidence that these two examples were 4. That's not what they will always be, but you'll always see the, the positive and the negative of the same number here. So this looks like it's going to be a huge number. 16 times 4 is negative 64. So the y-coordinate is negative 64. So the vertex is 1, negative 64. So since I haven't really drawn in any points that use the y-axis, I'm going to be a little bit creative here. Maybe I'll just make the, instead of -2, I'll go up by 10. So let's make that -20, -40, -60, -80, -100, 20, 40, 60, 80, 100. I'm going to keep the x-axis values the same because I needed to have nice low numbers, but here I needed high numbers to fit it on. So, you know, you'd prefer to keep the scales the same, but sometimes it just won't work. So in this case, at least we'll be able to show our point. So -64, so it's 1, and then -64 is right about here. Okay, and that's the vertex. And again, you know, you can see, you can kind of imagine a nice parabola here. So I'm going to do my little cup, make sure it's kind of pointing towards the other points that you see, and nice and smooth in both directions. Don't be afraid to erase and redraw if there's part of it you don't like. And there's our graph. So that's a pretty nice looking graph. So again, it's the factored form is pretty powerful. Gives you the x-axis, the x-intercepts directly, and from that we can get the vertex. And using those 3 points, we can always come up with a nice looking sketch. Okay. We can't do that with the vertex form. Vertex form just gives us the vertex. Now we can use our, we can graph using the vertex form with the base point transformations, but that might not give us the x-intercepts. And those x-intercepts, you're going to see they're going to be pretty important. In a few lessons from now, we're going to be wanting to find the x-intercepts quite a bit. Okay, last question. This is a bit of a application question. So this is Dufferin Gate. This is actually in Toronto at the CNE, there's a big arch. And archways are usually parabolas in shape. Obviously, they open down. Also like the St. Louis Arch as well. So the Dufferin Gate is a parabolic arch, like I just said, and it's approximately 20 meters tall and 22 meters wide. Okay, so it's asking us to sketch a graph of the arch with the left base located on the x-axis 4 units to the left of the y-axis, and then label the x-intercepts and vertex. Okay, so since this is an application, we're going to use the x-axis is like the ground. So I'm going to run that across here. Should use a ruler. And then I'm going to have my y-axis going straight up. So right there is the point 0. And let's see, maybe I'll go up by, let's go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Should be good enough. And then I'll go back negative 2, 4, 6, 8, negative 10, 2, 4, 6, 8, negative 20. Okay. Now we'll put the scale on the y-axis in a sec. So it does tell us where to put one of the base. So kind of imagine it's going to be a parabola that opens down. We just need to get some points as reference so that we can draw that arch. So we want the left base, so that's where the left arch touches the ground, 4 units to the left of the y-axis. So that would be right here. 4 units would be here. So that's the left base. Now the right base will be somewhere over here. Now these numbers actually mean something in this. Usually they're just numbers, but in this case, this is going to be measured in meters. So this is the distance in meters. Distance in meters. Okay, so let's use our common sense and read the question, see if we can pull out something. Dufferin arch is a parabolic arch. Yeah. That is approximately 20 meters tall. We're going to use that in a second. and approximately 22 meters wide. Okay, so that's going to be helpful because if the left base is at -4, that means if I count 22 to the right, that's going to be where the right base is, the length of 22. So -4 plus 22 is going to be 18. So remember, I'm going up by 2's here. So that would be 18. So that's my left. Sorry, that's my right base of the parabola. So it's definitely going up like this. Okay, so we've used, sometimes it helps to kind of, put what you've used. So we've used the fact that it's 22 meters. We've done the 4 units to the left, and the only thing we haven't done is the fact that it's 20 meters tall. So that's going to help us get the vertex. So maybe I should do my scale. I have to make this graph go up to 20. So I can't use the same scale I did here because I would run out of room quickly. So I'll go up by 4's. So 4, 8, 12, 16, 20. So that's 20. And what's this measuring? This is measuring the height in meters. Okay, so that would be 20. So basically we know that the top of the Dufferin gate is going to touch along here because that's 20 meters high. So how do I know where that is? Well, this is where we go back to our last 2 examples. If I can find where the axis of symmetry is, that will tell me exactly where the vertex is. So do a little side calculation here. So it's x equals, and then I take my 2 x-intercepts in this case, so it's -4 and 18. So add them together and divide by 2. So that's going to be, I'll just do this in one step, that's 14 divided by 2 is 7. So the axis of symmetry, there's 10, 8, 7. If I run that up there, that will intercept with the height of the gate. So that point there is the vertex. And we know that coordinate is 7, 20. Okay, I might as well put these in too. That's -4 and that's 18, just to be clear. And now I'm going to complete the arch. Now it's a little bit compressed because of the scale vertically. I just couldn't use the same scale. So that's not quite as good as some of my other parabolas. I probably should make this a little wider. Sometimes you try to correct it and it ends up looking worse. Just do the best you can, okay? And that's why it's important to use pencil. Okay, now here's a really cool question. So we've got this diagram of this arch with the right coordinates. We've got the values of the x-intercepts and the vertex. And it says determine equation to model the arch. Okay, so from what we know here, remember this would be R and this would be S. So let's do that over here. R equals the first x-intercept and S equals second intercept. So if I make an equation, remember it's y equals A times x minus R times x minus S. Okay, well I'm just going to plug in my values of R and S. So y equals A, and then that would be x minus -4. So x minus negative is x plus 4. And then x minus S, which is 18, x minus 18 will be there. Okay, that's pretty good, but we're not quite done because we didn't write in a value for A. And remember, A tells you how compressed or stretched the parabola is, whether or not it opens up or down. So we can't just leave it like this. We've actually got to calculate the value of A for this very specific parabola. So what have we used from our graph? We've used the x-intercepts. And in order to figure out the A, all we need is one other point. We're going to substitute it in and figure out what A is. Okay. Now we have the vertex, which is fantastic, but it doesn't have to be a vertex you plug in. It just can't be the x-intercepts because we've already used them in the equation. So if somebody told me, oh, I know one other point and gave me the coordinates, I could use that as well. So I'm going to substitute in the vertex. So substitute 720. Okay, it's important to remember 7 is your x coordinate, 20 is your y. So I'm just going to find the y's and the x, change them. So I got 20 equals A, and I got 7 plus 4, right, because x is 7. 7 minus 18, 20 equals A, that's 7 plus 4 is 11. 7 minus 18 is negative 11. Okay, multiply those two together. We get 20 equals A times negative 121. So I'm going to bring this up over here. Okay, so we're almost there. Now, this looks a little weird because we're trying to solve for A. We're trying to get the value of A that makes, that makes this true. And usually when we have a number multiplying with A, it goes in front. The number goes in front. So I could, just to make you feel more comfortable, I'm going to now put that in front. So 20 equals negative 121A. So the negative 120 is multiplying with the A. So if I just want A, that means I divide both sides by negative 121. So when I do that, I get 20 over 121, put the negative sign in front, is equal to A. Okay, so what does that mean? Well, it's a negative number, the first thing, which validates the fact that our curve actually opens down, so that's good. And the fact that it's a very small number, it's between negative 1 and 0, that tells you it's compressed. So it's much kind of wider and fatter than the regular parabola. Okay, so are we done? Not quite. I'm going to take two things. Remember this version of the equation that we thought we were almost done? But then I said, well, we have to get A. So I'm going to start with that. And I'm going to plug in this A value that we just got and put both things together. So A equals negative 20 over 121. And then the rest of it, x plus 4 and x minus 18. There's my equation of this parabola, and you can see it's in factored form. Okay. Now people will ask, can I just make that into a decimal? And again, if you can't turn it into an exact decimal like 0.75 or 0.62, I wouldn't. But in this case, if you actually put this in a calculator, it turns into a never-ending decimal, which means you're going to have to round it. So in that case, leave it exact. Just leave it as the fraction. If you can reduce the fraction, right? If you can, divide the top and bottom by 2, go ahead. Like make the number smaller, but don't change the actual value. Okay, so that's kind of a cool thing. Like just given that information about the height and the width of the gate and where it's positioned on a grid, we can come up with an exact equation. Okay, so I'll leave it at that. We did 3 good examples on quadratic equations in factored form and the value, what's good about them. You can get the x-intercepts, and you can also get the vertex, which is a bonus. So you can come up with a nice graph of them, and it gives you 2 really important points. Not quite as important as the vertex, but the next most important things. So I've got some homework here for you to work on, so give that a try. And next lesson we're going to continue on with quadratics, and we'll see you then. Have a good day.